Hello guys, how you doing? Today is the second as well as the last session of tutorial for chapter 5 and also totally of fluid mechanics 1. Today I have a question for you, which is the combination of two sections. The first one is from section 5.2.2, the application of linear momentum equation, and the second is 5.3.2, which is about application of energy equation combined with linear momentum. The number of a question is 5.130 from the book of Monson 6th edition. The question is, we have two water jets collide as this in a homogeneous figure. The question wants us to determine the speed v and also the direction of the theta. And the second term is to identify the loss for the fluid particle following from point 1 to point 3. And also from point 1 to from point 2 to point 3. The specific gravity is negligible. So, in order to have this problem solved, I'm going to erase this area in order to have enough space to have it solved. So, yes, it's kind of tricky to have them erased. Here I have my notes. In order to have the solving of part A, which is V, identifying V and the theta, we have to write the the momentum equation from 2 to 3 and also 1 to 3. From 2 to 3, we have linear momentum equation as this, minus rho2 v2 v2a a2. This is B, plus rho3 v3 v3 cosine theta a3, because it's going to be merged in the x direction. From point 1 to point 3, we have the linear momentum equation as minus rho1 v1 v1a1 plus rho3 v3 v3 sine theta a3. So, and also the conservation of mass, which means rho1 a1, rho1, rho a1 v1 plus, this is a minus because we have the normal direction and the velocity direction in both sides of region 1 and region 2 are in the opposite direction. Since we have it as this, rho2 a2 v2 plus rho3 v3 a3. This shall be equal to 0, as same as this and this. So let me just have this part erased. No, we need it. Actually, we need it. 1, 2, and 3. So, combination of equations 1 and 2, we can have the tangent of theta as v1 to power 2 a1 divided by v2 to power 2 a2, which is these are the circular areas. A1 is p 0.1 to power 2, 0.12 to power 2 divided by 4, and A2 is pi 0.1 to power 2 divided by 4. V1 is equal to 4 meter, 4 meter per second, and V2 is equal to 6 meter per second. Doing the whole calculation, we have the theta as 7.2. It's the tangent inverse of this equation. So we can identify the V3 at the outlet based on having the theta and combination of equations 1 and 3. Let me have this erased. Yeah. Combination of equations 1 and 3 gives us the velocity of point 3 as V3 is equal to V2 to power 2 A2 divided by cosine theta V1 A1 plus V2 A2. I'm hoping that you have already written the information. Doing the whole calculation, we can have the velocity at point 3 as 4.29 meter per second. So we have identified the velocity and the direction. V3 is equal to 4.29 meter per second. So we have to identify the energy loss. It's a really tricky point here. Using equation 5.64, neglecting the pressure as well as the elevation, we can have the available energy associated in the flow of control volume as minus U1 plus V1 to power 2 divided by 2 minus U2 plus V2 to power 2 over 2. There's a mass flow rate here, 1, mass flow rate 2 in here, plus U3 plus V3 to power 2 divided by 2 M3 dot. This is equation 4, which has to be equal to 0 in order to have the conservation of mass. And also for the conservation of mass, there is another equation which is M1 minus M1 minus M2 dot plus M3 dot is equal to 0, which is equation 5. Combination of equations 4, which is this, and 5 gives us the rate of available energy loss in the flow, which is M1 dot multiplied by U3 minus U1 plus M2 dot U3 minus U2 is equal to M dot 1 multiplied by V1 minus V3 divided by 2 plus M dot 2. Here we have V1 minus V2 divided by 2. V1 minus V2 divided by 2. We can have the M1 as rho V1 A1. and also M2 dot as rho V2 A2. Just we need to substitute the values. Here at the left side, it means the total rate of energy loss. Excuse me, this is getting less color. Loss in the flow. Total rate of energy loss in the flow. M1 multiplied by U3 minus U1 plus M dot 2 multiplied by U3 minus U2 is equal to M dot 1 multiplied by V1 minus V3 divided by 2 plus M dot 2 multiplied by V1 minus V2 over 2. M dot 1 is rho V1 A1 and M dot 2 is rho V2 A2. So we just have to substitute the values. V1 is 4, V3 is 6, and excuse me, the V3 is 4.21 as here. And also the density is 999 kilogram per cubic meter, and the A's and the areas are PD1 to power 2 over 4, and A2 is PD2 to power 2 over 4. Doing the whole calculation, we can have the total rate of energy loss in the flow as 558 Newton meter per second. Be careful. We just need to have the multiplication of 1 Newton meter per square second in order to get everything converted to the Newton meter per second. So this was the whole thing. At this moment, I really apologize you for getting the less color of the problem solving. I've just demonstrated to you, but if you have any questions, please don't hesitate to ask them via email or comments of this video. I'm really glad that you have accompanied me till this moment of the video. Most importantly is that please don't forget to subscribe the whole channel in order to get the notification of all upcoming instructional as well as the tutorial sessions. I bid you our farewell. See you in the next course.